Hello, and I welcome you to the second section of the module 1, wherein we're going to talk about Azure Data Factory components. In the previous section, we got started with Azure Data Factory. We spoke what it is and when we should use it and few of the key components of Azure Data Factory. So before getting into the components, let's probably try to understand what Azure Data Factory gives you in a nutshell. So there are two specific versions, V1 and version 2. Version 1 was the first version, as the name suggests, wherein it was more of a JSON based template, wherein it was less of a graphical interface when compared to version 2, which is the latest one. And that's what we're going to create in our upcoming video. It provides you more robust and GUI based interface to get started with your Azure Data Factory journey. It supports majority of the APIs, so you could automate your entire data factory instance, data factory activities and pipeline, which we're going to understand using PowerShell, .NET, Python, and also the Terraform, which is famous for infrastructure as a code. So you could just use the DSL language and create Terraform scripts to automate your entire data factory infrastructure. It integrates with majority of the Azure resources like Key Vault, Monitor, automation for security purposes. Just to clear out a myth, Azure Data Factory is not any data storage tool. Rather, it's an orchestrator, which means it accumulates all of your tasks together, all of your data tasks together, and gives you a graphical interface to provide you with the data integration and transformation layer that work across your digital transformation, so that it enables us to construct our ETL or ELT processes via code-free task. And that's the unique selling point of Azure Data Factory. It's a tool which provides you a code-free platform, few of the famous or few of the generic tool which a data pipeline needs to have, which a data engineer would needs to perform, and all of these tools are by default included in Azure Data Factory. So let's start understanding what are the key components of Azure Data Factory is. There are 6 specific components. The first one is integration runtime. Then we've got the data flows, we've got the linked services, we've got data sets, activities, and pipeline. So let's try to understand the first one, which is data integration runtime. Integration runtime is the base, is the compute infrastructure to run all your activities, all the pipeline, the data processing, data transformation, copying of data from multiple different sources, data sources, be it within Azure or outside Azure. So all of those computation happens on top of integration runtime, which is the compute infrastructure used by Azure Data Factory. So there are 3 types of runtime which is available under Azure Data Factory. First one is the Azure Integration Runtime. This is this is Azure hosted, wherein you don't need to do anything. It comes by default whenever we are going to create our first Data Factory instance. In the next video, we're going to see that the Azure Integration Runtime comes by default, and it provides you with all the capability to run your pipeline, your infrastructure, your data engineering workloads on top of your integration runtime. So it provides all of them for you. When should you use Azure Integration Runtime? So in case you wants to make a public call to other services also beyond your Azure. So let's suppose you want to copy some files from Amazon S3 or Google Cloud Storage. You could use the Azure Integration Runtime, because it provides these activities without any network restriction between multiple cloud data source. So if you want to make unrestricted access to multiple data source, consider using Azure Integration Runtime. The next one is self-hosted integration runtime. The self-hosted integration runtime sits behind your private network. So your data stores coming from super secret devices, and these are research devices, and you want to make sure they always sit behind your private network. In those scenario, you could just use the self-hosted integration runtime. Let's suppose you have some IoT devices which is sitting on your on-premises network, and you need to copy those data from your on-premises, run some transformation, and put it into Azure SQL Service. So in those scenario, you could just install a self-hosted integration runtime on your on-premises machine. So this could be a virtual machine, this could be an Azure machine as well, sitting on your internal network. The last one is the Azure SQL Service Integration Service runtime. This is specifically needed when you want to lift and shift your existing SSIS workload. You can create an SQL Server machine on premises, and then which can be provisioned in a private network, and those network would be used to a dedicated VM to run your all your SSIS package. You can bring your own SQL Service database or manage instances for the catalog of SSIS packages and projects. So these are the three different runtimes available on Azure Data Factory. Azure IR is the by default one which is available whenever you create your Azure Data Factory. The best part is you don't have to worry about the patching, the upgrades, the scaling, any vulnerability. Everything is managed by Azure. The self-hosted, which wherein you create a virtual machine or an on-premises machine which sits on a private network, and you got to take care of obviously all the patching upgrades and make sure that they are well maintained over the time. The third one is Azure SSIS. If you want to lift and shift your SSIS packages, Azure SSIS is for those purpose. So next component in Azure Data Factory is linked service. So linked service is a service which is very much like a connection string. If you've worked with any of the services in Azure, let's suppose your data is coming from multiple sources, be it Amazon, S3 buckets, or your data is stored in Azure Blob Storage or Cosmos DB. Now, Data Factory needs to read the data sets which is sitting on all of these data sets. Now, in order to read these data files, whether it's a JSON or it's a text file or a CSV file or Parquet or Avro file, Data Factory needs to read this file. In order to read these file, Azure Data Factory needs to communicate with these data sources. In order to communicate, it needs to create a linked services which can talk to these services and perform some crude operation, which is primarily reading the data, pulling the data from there, and then injecting the data in some sort of destination, could be SQL service. So one of the link service in this scenario, one of the link service going to be between Azure Data Factory to the S3 Azure Blob Storage or Cosmos DB. This is going to be one link service so that it's going to speak seamlessly and perform the operation it needs to. And the second link service, it's going to be your SQL service wherein it's going to push the data. So there's going to be two link service in this scenario, and all of these link services are connected with your integration runtime, because anything and everything performed, computation performed on Data Factory happens on the data integration runtime. Moving on to the next one, the triggers. Now, in order to run these copying of the data or moving data from blob storage to another SQL server, you need to trigger it. So there are multiple triggers available in Azure Data Factory. One of them is a scheduled trigger, which let's suppose you run every day at 10 p.m. a nightly job which can collect the data and run the quick transformation and push it to the SQL server. So that's going to be the scheduled. It's similar to your cron job which runs daily. Now the second one is the tumbling window. Let's suppose you want to make sure that it's a streaming job and you want to run every 2 hours these pipeline, and these should be able to run every 2 hours every day, pulling out data from some sort of data stores and then push it to some destination. Now this is called a stumbling window, and the last one is event based. So let's suppose you want to make sure that whenever a new file arrives in your Azure Blob Storage or S3 bucket, you want to make sure that your pipeline gets triggered and your data transformation happens in those trigger based event. So these are a few of the triggers available and can be used. So let's try to accumulate all of them together and understand what are the dependencies. So you've got a pipeline. Pipeline is where you define the activities in your Azure Data Factory. This is going to be contains a group of activity that ingest data. Now in order to ingest data, first thing we need to have a pipeline, obviously, and underneath the pipeline we need to have some sort of trigger wherein a data engineer initiates it manually, or there's a tumbling window, or let's suppose a data has just arrived into your SQL Server. Now once the data has arrived and you have triggered the pipeline gonna start performing those activities. Now there could be multiple activities and all of these activities could be linked to each other. The first activity gonna be read the data from S3, move the data from S3 bucket to Azure Blob Storage, then transform it and then send it to. Now there could be scenarios when your data fails, and when the data fails, on error do some action, send out an email notification to your administrator or retry the jobs. So these backfill scenarios or retry capability scenarios are supported in Azure Data Factory, and it is only supported in tumbling windows at the moment. So just keep those things in mind, so that whenever you want to schedule a trigger, do that with the tumbling window, so that on errors the retry capabilities can be achieved as well. Let's suppose you've achieved one of the pipeline, you ran on one pipeline, and upon the successfulness of that pipeline, you want to make sure that it triggers another pipeline. So that's going to be pipeline under condition. You have got one pipeline, and on success of that pipeline, you want to trigger another one. So all of these happens on a runtime, and that runtime could be your Azure IR self-hosted or Azure SSIS. Let's try to take another scenario wherein you could visually understand what happens behind the stage. So you've got your data set. Data set is kept in your Azure Blob Storage or S3 bucket in the form of this. This is your actual data on which the transformation going to happen. Now this could be files, tables, unstructured data as well, activities, which is in on the center of the screenshot, consumes the data, and this runs in the pipeline. As you can see, a pipeline is on the extreme right, and the activities is actually connected with the linked service, which runs on your integration. Linked service is always connected with your data source, which is S3 or Azure Blob Storage, and actually it consumes the data, and activity is the one which calls the data set inside your data source using the linked service and perform some transformation on those top of those data sets. On all of this happens inside a pipeline. Now this could be activity of just one activity of group of multiple activities. So that's how your pipeline works. That's how your pipeline activity, data sets, data source, and linked service are all of them are interconnected to each other. All right, I hope this was informative. In terms of summary, we could start with Azure DevOps Data Factory components. Azure Data Factory components, we could understood what pipelines are, what activity is. We spoke about linked service, we spoke about integration, we spoke about triggers and different type of triggers as well. When should you use certain type of triggers? When should you use a certain type of integration runtime? And what are linked services? They're pretty important in establishing a connection between your different data sources. We also understood about what each of these components kind of ties back together and how the components relationship actually works together. This is going to be foundational and it's going to be helpful in our upcoming videos. In our next section, we're going to get started with creating Azure a data factory using the GUI, and we're going to also create the storage account which we're going to use to copy data from one storage account to another one. I hope this fundamental foundational video was helpful, and I'm going to see you in the next one. Thank you.